rational here? Anyone? You guys remember?
No, ma'am, I don't remember.
No? Okay. Okay, let's go back to the beginning. Hamza, you said rational numbers are from 0 to infinity, right? What about
Yes, ma'am.
negative numbers? Negative numbers are not rational.
Mm, no, ma'am, I think so because negative numbers are starting from minus.
Okay. So they are not rational numbers.
Yeah.
What do you think, Abdul Jabbar?
Ma'am, rational numbers are numbers which can be expressed in the form of p by q, where p and q are co-integers and p is not equal to 0.
Hmm. Good. Okay. So abhi jo aapne the definition that you gave, Hamza, from 0 to
Yes, ma'am.
infinity, from 0 to infinity. Let's see what that definition is. See, when you first started counting, right? Remember when you first came to school, when you first entered school,
Yes.
what type of numbers did you start learning when you first came to school? What was the first numbers that you learned? I'm asking both of you. What were the first numbers
First,
that you learned in school? One, two, three.
Yeah.
Is that correct?
yeah, yeah,
Yeah. So starting from 1, 2, 3, 4, 5, 6, and then so on till infinity. These are called, what are these numbers called? Can someone tell me?
rational numbers. Yeah,
These are called natural numbers.
yeah,
Natural numbers, or sometimes they are also called counting numbers. You must have learned them as counting numbers.
yeah.
Okay. But when we're talking about number systems, we call them natural numbers. Why? Because when you start counting something, if I ask you to count the number of students in your class, from where do you start counting? From which number will you start counting?
From one.
1.
From one. That is why, you start counting like this: one, two, three, and so on. So that is why we call them counting numbers, or also natural numbers. And then when you grew up a little bit, you studied, you also learned about the number zero, right? Zero is
Yeah,
nowhere over
yeah.
here. Zero is not found in natural numbers. Zero
Yes.
is found in a number system called whole numbers. So
Whole
these are all
numbers.
different systems of numbers. Okay. And when you have all the natural numbers, all the natural numbers plus zero, then this set is called whole numbers. Is this clear?
Yes, ma'am.
Yes, ma'am.
Okay. So whole numbers is nothing but natural numbers plus zero. And then when you grew up a little bit more, you also studied about negative numbers. All of these natural numbers along with their negatives. And what are they called? Can someone tell me what negative numbers and positive numbers together, what are they called?
Integers.
Like,
Integers.
very good, integers. So these are called integers. Okay. Can someone tell me, is 2 by or 1 by 4, is this an integer?
No, ma'am.
No, it's not an integer. Integers are basically whole numbers and they are negatives, right? These are integers. And then you learned about, in your seventh grade, you also learned about something called, sixth grade, in fact, fractions and decimals. Remember? So
Yes.
all your fractions all your fractions, they come under rational numbers. Rational numbers are basically, that's another word for fractions. Why? Where does this, again, we are coming at the same question, where does this term rational come from? It comes from this ratio. You guys remember what is ratio?
No, ma'am.
No? Abdul Jabbar, do you remember?
Yes, ma'am.
What is ratio?
No, I don't know how to take.
Okay,
think
you remember the word ratio, but you don't know how to, you don't remember how to define it. Is that correct?
Yes, ma'am.
Can you give me an example of a ratio then?
And the number of girls to the number of boys in a class, ma'am.
Very good. The number of girls to the number of boys in a class. An example could be, let's say, 1:2, right? That is a ratio. And we also write this as 1/2. Now this 1/2, it is a fraction. So this is a ratio and this is a fraction. Ratio and fractions are very closely related. So that is why you have in the definition of rational numbers, the one which Abdul Jabbar just told us, that it can be written in the form of P by Q. What is P by Q? It's a fraction, right? So what are
Yes.
rational numbers? Rational numbers are all those numbers that can be written as fractions. Something upon something. Okay. Now, what kind of numbers can we have in the numerator and what kind of numbers can we have in the denominator? Can someone tell me? Can we have anything?
Yes.
Positive numbers.
Abdul Jabbar, what were you saying?
Positive and negative both.
Positive and negative numbers को क्या बोलते हैं? What are they called? Positive and
Integers.
negative numbers. Integers, exactly. So the numerator and denominator, they can both be integers. Can someone tell me, is 0 an integer?
Yes, ma'am.
Yes.
Yes. Can we have 0 in the numerator? Is it okay to have 0 in the numerator?
No.
Who was this? Was this Abdul Jabbar or was this Hamza? Who said no?
Sir.
Both,
Okay. You said it's not okay to have 0 in the numerator. I'm talking about numerator right now, not denominator. Why is it not okay to have 0 in the numerator? Okay, let's say you have 0 upon something. Let's say 2, 0 upon 2. What is 0 divided by 2?
2, ma'am. Sorry, 0, 0.
0. Is this not a rational number?
Yes, it is.
It is.
It is. So why is it not okay to have 0? So we see that it is okay to have 0 in the numerator. All right. But is it okay to have 0 in the denominator?
Hmm.
Yes or no?
No.
No. Why not? Why is it not okay to have 0 in the denominator? Think about it. What will happen if we have 0 in the denominator? Yes. Okay. Can you have any number divided by 0? For example, can you have 5 divided by 0? 5 by 0. What is this going to be equal to?
It will be 0.
Acha. Just now you told me that 0 by 2 or let's say 0 by 5, that is also going to be 0. 0 by 5 is going to be 0. And you're telling me that 5 by 0 is also going to be 0. Think about it. Okay. See, when we divide something, let's say if I ask you what is 5 divided by 5, okay, then what do? You divide it like this: 5 divided by 5, and then you start reading the table of 5, है ना? You start reading
Yeah.
this, the table of the denominator. You say 5 multiplied by 1 gives me 5. So what is the answer to this? 5 divided by 5 gives you 1. Right? This is how we solve it.
Yeah.
Now let's say if I have 0 divided by 5. 0 divided by 5, we're going to write this as 0 divided by 5. Now start reading the table of 5. 5 multiplied by what will give you 0? Like over here, we had 5 multiplied by 1 will give you 5. So now I'm asking you, 5 multiplied by what will give you 0?
0.
5 multiplied by
0.
0.
Very good. 5 multiplied by 0 will give me 0. So the answer to this is 0. Clear till here? यहाँ तक clear है सबको?
Yes,
Yes,
ma'am.
ma'am.
Okay. Now the question is, why can't we have this? This is the main problem. 5 divided by 0. That means 5 divided by 0. Now start reading the table of 0 and tell me if you can ever get 5.
No.
Is it possible?
No.
No, it is not.
It's not possible. You say 0 ones are again 0, 0 twos are 0, 0 threes are 0. No matter which number you say, 0 into any number, no matter how big the number is, you're always going to get 0. You're never ever going to be able to reach 5. You can never reach this number. Are you understanding?
Yes, ma'am.
Yes. So that is why we say that 5 divided by 0 is not defined, or in other words, it is infinity. Okay, it's not defined. Infinity basically means something that we can never reach. Over here also, this number is something that you can never reach. Are you understanding?
Yes, ma'am.
Okay. Um, Now, students, if at any point you think that you're not able to understand a particular thing, you can always just raise your hand or unmute and ask the question that, ma'am, I didn't understand. Or you can also send me a personal message on Zoom itself that you didn't understand. Okay, just don't we are not going to go forward without you understanding each and every single thing. So if there's anything that you haven't understood, please point it out. Okay, I hope that's clear.
Yes, ma'am.
All right, so now we saw why can't we have 0 in the denominator, right? So how do we define rational numbers? We are going to define it as a fraction, basically, where it is some number divided by some other number, and the numerator can be anything, any integer. The denominator can also be any integer
Zero.
except for 0. So let's see the official definition of a rational number. It goes like this: a rational number rational numbers are those that can be expressed in the form of P upon Q. P upon Q means numerator upon denominator, just like we did over here. This is our P and this is our Q. So they can be expressed in the form of numerator by denominator, where P and Q are both integers, right? They can be any integer at all. They are integers. And Q is not equal to 0. P can be 0, but Q cannot be 0. So this is the definition of rational numbers. Clear?
Yes, ma'am.
Okay. All right. Just a minute. Okay, now let's see a few statements, and you have to tell me whether these statements are true or false. Okay.
Yes, ma'am.
Keep these into consideration. The types of numbers that we have just studied. Natural numbers. These are all number systems. Natural numbers.
Whole number.
Excuse me. Whole numbers, integers, and rational numbers. We have so far studied four types of number systems. And by the way, these all number systems, they come under real numbers. Okay, these are all real numbers. Okay, so now just keep these in mind and answer these questions. So the first statement I'm going to tell you, you have to tell me whether it is true or false. Okay, every whole number is a natural number. Is it true or false?
Yes, ma'am. It is true.
It is true. Yes, every whole number is a natural number except for
Zero.
Zero.
zero. Zero is not a natural number, right?
Yeah.
Zero is a whole number, but it's not a natural number. So we cannot say that every whole number is a natural number. Are you understanding why
Yes,
we
ma'am.
can't say it?
Because zero is in whole number, it starts with zero, and natural number it starts with one.
Zero, yeah. Zero is a whole number, but it's not a natural number. So is every whole number a natural number? No. On the other hand, is every natural number a whole number? Is every
Yes.
natural number a whole number?
Yes.
Yes.
Yes, it is. Is every integer a rational number?
Yes, ma'am.
Yes, ma'am.
Is every rational number an integer?
No, I didn't understand the question.
The question is every rational number, I'm sorry, is every rational number an integer? Did you understand the question?
Yes, ma'am.
Yes.
Okay. Can you tell me, is every rational number an integer?
Yes, I think so.
Yes.
Yes. Okay. How about the rational number uh, 2 by 3? Is this a rational number?
Yes, ma'am.
Is this an integer?
Yeah.
No.
It's not an integer. Is 1 by 2 an integer?
No.
No. Integers are just whole numbers and their negatives, not fractions. Fractions don't come under integers. So is 1 by 2 an integer? No, it's not. But it is a rational number. So my question was, is every rational number an integer?
No.
No, every rational number is not an integer, whereas every integer is a rational number. How is every integer a rational number? You can take any integer you want, no matter which integer. You can take any integer you want. Let's say this 3, okay? 3. This 3 can be written as 3 by 1. P by Q के form में लिखना है. We're supposed to write it in the form of P upon Q. There you go. We have written it in the form of P by Q. So this integer can be written as a rational number. So yes, every integer is a rational number. Is this clear?
Yes, ma'am.
Okay. All right. Can someone please tell me, can you name any 5 rational numbers between 1 and 2?
Can we write it down?
Sorry.
Can we write in our books and write?
Yeah, sure. Take your time. See, let's draw the number line. Okay. Here we have 0, 1.
And we said 1 and 2, right?
Yes, between 1 and 2. Hamza, are you solving it?
7 by 6, 8 by 6,
7 by 6. Okay, just a minute. 7 by 6, 8 by 6.
9 by 6,
9 by 6,
10 by 6,
10 by 6,
11 by 6.
and 11 by 6. Very good. Hamza, are you sure you
Yes, ma'am.
understood this? How are we getting this? Did you understand?
No, ma'am.
Okay, no problem. We shall go through it. Okay. See, what you can do is there are many ways to do this. Okay. One of the ways is this. You say, okay, between 1 and 2, I need rational numbers. So between 1 and 2, you have 1.5. Yes or no?
Yes, ma'am.
1.5 means it can be written as 3 by 2. Between 1 and 2, you have 1, 1 by 4. You have 1, 1 by 5. All of these numbers. So what we can do is, instead of just randomly picking up numbers, we can call this, we can say 1 can be written as 1 by, or it can be written as 10 by 10, and 2 can be written as 20 by 10. Equivalent fractions, do you remember, Hamza, what are
Yes,
equivalent
ma'am.
fractions?
Yes.
Yeah, so you know that 1 can be written as 10 by 10, right? Yes, Hamza?
Yes. Yes. Yes, ma'am.
Yeah. So the thing is, you might ask, why only 10 by 10? Why not some other number? 1 can be written as 5 by 5 also, 6 by 6 also, 7 by 7 also. Why only 10 by 10? So the thing is, over here, it's totally up to you what you choose. You can even choose 5 by 5, but then whatever you choose, make sure that the fraction that you are converting 2 into, that also has the same denominator. Just make sure that both of their denominators are the same. Now, if you choose 5 by 5, the problem with that is, if you choose 5 by 5, your 2 will have to be 10 by 5. Yes, 10 by 5 is
Yes,
equal to
ma'am.
2, right? So your 2 has to be 10 by 5. Now you can't find 5 rational numbers between these two. One will be 6 by 5, 7 by 5, 8 by 5, and 9 by 5. Right? Between 5 by 5 and 10 by 5, you're only getting 4. So that's why we try to choose a denominator which is big enough so that we can find enough number of whatever it is that we need. Are you understanding, Hamza?
Yes, ma'am.
Yeah. So that is why Abdul Jabbar over here, he took 6 as the denominator. How? He said, well, 6 by 6, this is my 1, right? 6 by 6 is my 1. And 12 by 6, 12 by 6, this is my 2. So between these two, I can get 5 rational numbers. What you can also do is to keep things simple. You can also have 10 by 10 and 20 by 10. So between 10 by 10 and 20 by 10, can you find any 5 rational numbers, Hamza?
Between
Between these two, 10 by 10 and 20 by 10. 10 by 10, remember, this is your 1, and 20 by 10 is your 2. Between these two, you are supposed to find rational numbers. Can
okay,
you
ma'am. I'll
find?
try.
Yeah. Tell me then.
Yes, ma'am, I can.
Huh. Tell me.
Like 11 by 10,
Very good. 11 by 10.
12 by 10,
Yeah, 12 by 10 and 13 by
13 by
10.
10, 10,
Hmm.
14 by 10.
Yeah. So we have got 5 rational numbers between 1 and 2. Is this clear, Hamzat?
Yes, ma'am.
Okay. All right. Um, Now let's come to the first exercise. Exercise 1.1. Okay. The first question. Someone please read it out.
Yes, ma'am. Is 0 a rational number? Can you write it in P by Q form, where P
Hmm.
and Q are integers and Q is not equal to 0?
Yeah. So the summary of the question is basically, is 0 a rational number or not? What do you guys think?
Yes.
Yes.
Yes, it is a rational number because we saw that 0 can be written in the form of 0 by any number, not just 5. You can write it as 0 by 1, 0 by 2, 0 by 3, whatever, 0 by some other number. That is why you can say that 0 is a rational number. Is it clear?
Yes, ma'am.
Okay. Now let's do the second question. Let's do the second question. Or let's do one thing, just a minute. Leave the second question for homework. Take the second
Okay.
question as homework. Let's do the third question in the class. Yeah. Third question. Can you read it out, Hamza?
Yes, ma'am. Find 5 rational numbers between 3 by 5 and 4 by 5.
Yes. Okay. Hamza, can you please tell me how are we going to do this?
Yeah, first we should like multiply it by 10, 3 into 10 and 5 into 10. And same we'll do to 4 by 5 also. 4 into 10 and 5
Very
into
good.
10. Then we'll find it
Okay. Very
between.
good. Huh. Good. Now find it and tell me 5 rational numbers.
Yes, ma'am.
Abdul Jabbar, you can write, you can wait for Hamza to finish and then you can tell your answer on by muting yourself. Or the other option is you can also write it in the chat box. Okay.
Yes, ma'am.
Whatever is more convenient for you.
Yes, I'm finished.
Finished? Abdul Jabbar, are
Yeah.
you done?
Yes, ma'am.
Okay. Hamza, tell me your answer.
32 by 50, 50.
Okay.
33 by 50. And then 34 by 50.
Hmm.
Then 35 by 50.
Hmm.
Then 36 by 50.
What about you, Abdul Jabbar? What did you write?
19 by 30, 20 by 30, 21 by 30, 22 by 30, 23 by 30.
Okay. Okay. So what you basically did was you multiplied it with 6, right? 3 into 6, 3 by 5, right? And
Yes,
you
ma'am.
got 18 by 30. And then you multiplied 4 by 5 into 6. And then you got 24 by 30. So then you found 5 numbers between these. Okay, good. Both of you, your answers are correct. So great. And for the second question, please remember that's your homework. You have to finish your homework and come. All right. Please do not come in the class unprepared. Your homework should always be complete. Now let's come to the fourth question. Yeah, we've already done the first part. So can someone please try and recall first one? Natural number. Is every natural number a whole number?
Yes. True.
No.
Hmm?
Ma'am, is every natural number a whole number?
It is true,
If
ma'am.
you're
Yes, ma'am.
yes, it is true. See, if you're ever getting confused, just try writing down what all natural numbers do you know and what all whole numbers do you know, and then you can compare them. So yes, it is true. Second one, is every integer a whole number?
No, ma'am.
No. Okay, can you give me examples?
-1 is an integer, but not a.
Very good. So this one is false because you also have to give reasons in this question. You have to give reasons for your answer. So reason over here is we have negative integers, right? Negative integers are not going to be whole numbers.
Because whole numbers doesn't have negative numbers.
Sorry.
Integers have negative numbers, but whole number don't have.
Yeah, integers are negative and positive both, but whole numbers are only positive. Now let's come to the third part. We've done this one also, I think. No, we've not done this. Every rational number is a whole number. True or false?
False, ma'am.
Can you give me an example?
Yeah, like every rational number is like start. It can be start from any like zero also. It can be start. Uh,
Okay. I am asking you to give me an example. Jesse, Abhi over here, we had an example for the second one that
no.
-1 is -1 is an integer, but it's not a whole number. So is tarah ke I'm asking you for an example. Give me an example for a rational number which is not a whole number. Example.
Every rational number is a
Abdul Jabbar, any examples?
-1/2 is a rational number, but not a whole number.
Very good. -1/2 is a rational number, but not a whole number. Similarly, you have you can have 2/3. 2/3 is a rational number, but it's not a whole number. है ना? Whole क्यों कहते हैं किसी number को? Because see, there are two different things. One thing is whole number, one thing is fraction. Whole number and fractions are kind of like opposite. You know why? Fraction means a part of something. Like if I say half, it means half of something. Whole, on the other hand, if I say one whole, that means there are no parts. We're talking about the entire thing. Like if I say one pizza, then that means the entire whole pizza. If I say half of a pizza, that means it's going to be a part of the pizza. So fractions and whole numbers are kind of opposite things. Not exactly opposite, but kind of. So over here, the question was every rational number is a whole number? No. Okay, can you name some rational numbers which are whole numbers? Like over here, you gave me example of minus 1 by 2. That is, this is a rational number, but not a whole number. Can you give me an example of a rational number which is also a whole number?
1 by 1.
Very good. 1 by 1. This is a rational number and whole number also. And how about 4 by 2?
Yes, ma'am.
Yes, 4 by 2 can be written as 2. So this is a rational number also and a whole number also. So I hope this is clear.
Yes, ma'am.
Yes.
Okay. All right. Now, till 8th grade, you had studied only about rational numbers. In your 9th grade, we're going to study also about something called irrational numbers. Can you guess what could be the meaning of irrational numbers?
Numbers that cannot be expressed in the form of p by q.
Very good, right? Which is basically the opposite of rational numbers. Okay, what can you give me some examples of irrational numbers?
10 by 3.
10 by 3.
No, it's not.
10 by 3 is a rational number because this is p, this is q. Both of them are integers and the denominator is not equal to 0. So this is a rational number.
Ma'am, I mistook it for this non-recurring.
Hmm?
I mistook it for this one, non-recurring.
Right now we are talking about irrational numbers. Can you give me an example of irrational number? Okay. See, let's see where this concept of irrational numbers came from. Okay, let's see where it came from. So let's say you have a triangle. Okay, do you guys remember Pythagoras theorem?
Yes, ma'am.
Yes.
Pythagoras theorem. What does the Pythagoras theorem state, Hamza?
What, ma'am?
What is the Pythagoras theorem? What does it say? Abdul Jabbar, do you remember what does it say?
Yes, ma'am. AC square is equals to AB square plus BC square.
Okay, in other words, if you take the hypotenuse, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So if the length of this is your x, length of this is y, and length of this is z, then you can say that x square is equal to y square plus z square. This is the Pythagoras theorem. So, okay, let's say you have some number, your triangle, the measures of the sides of the triangle are 3, 4. Can you tell me what will be the hypotenuse? This is the hypotenuse. What will be the measure of the hypotenuse? Use the Pythagorean theorem and tell me.
5.
Very good. It will be 5. Hamza, are you sure you understood here how we got 5?
No, ma'am.
Okay. See, Pythagoras theorem we saw that this number square plus this number square will give you is equal to this number square. Okay. Let's see what that means. It means that 3 squared plus 4 squared will give you, let's call this hypotenuse as x. Okay, let's call it as x. It will give you x squared. Okay, Hamza?
Yes, ma'am.
Yeah. So what is 3 square, Hamza?
3 square.
What is 3 square? 3 into 3?
3 into 3, 9.
9. So 3 square is 9. Hai na? What is 4 square?
4 square, 16.
16. This gives you x square. So basically, sorry about that. X square is 9 plus 16. What is 9 plus 16? Hamza.
9 plus 16. 24.
20?
No, sorry. Yeah, 24, 24.
25.
Oh, yeah.
Can you name a number whose square is 25? Yani some number which multiplied with itself gives you 25.
5 as a 25.
Yeah. That is how we got x is equal to 5. Got it?
Yes, ma'am.
Okay. So we, or in other words, यहाँ पे बीच में let's write the missing step. X is equal to square root of 25. And that gives you x equals 5. Sorry for that. Now let's say we have a triangle in which these two sides are 1 and 1. Now both of you find out what will be my hypotenuse. Hurry up. Hamza, start calculating. The hint is, yes, Abdul Jabbar, that's correct. See, the hint is, you're going to do it like this. Let's call this x, okay? 1 square plus 1 square is going to give you what, Hamza?
1 square plus 1 square is, it will give x square.
X square. And what is 1 square? 1. Yes?
Yeah.
Again, 1 square is 1.
1.
So, that means my x squared equals 1 plus 1. What is 1 plus 1?
1 plus 1, 2.
2. Is 2 a perfect square? Is 2 a perfect square? That means, can you have any whole number which you multiply by itself and it gives you 2? You don't have. Why? Because 1 square is 1. 2 square is
2.
What is 2 square, Hamza?
2.
What is 2 into 2?
4.
4.
4.
So 2 square is 4. So beach mein over here you want to get 2 somewhere, but you can't. So that means ye jo number hai over here, the
Yes,
square root of 2, that is not anywhere in the whole numbers, or in fact even in rational numbers. So square root of 2, basically x is equal to square root of 2. This is an irrational number. Why is it an irrational number, Hamza? Because we cannot express root 2 in the form of p by q. No matter how hard you try, you cannot express it as p by q, where p and q are integers. So that is why this root 2 is called an irrational number. Okay? Is it
okay.
clear?
Yes.
In the next class, we're going to see more irrational numbers. For example, Hamza, what is the formula of circumference of a circle?
I think 2 pi r.
Very good. Abdul Jabbar, what is the formula of area of circle?
Pi r square.
Pi r square. What is this pi?
22 by 7.
22 by 7? Pi is 22 by 7. Are you sure?
Yes.
See, this is the biggest misunderstanding that a lot of students have. Pi is not 22 by 7. Pi is an irrational number. See, the difference between pi and 22 by 7 is this. 22 by 7 is a rational number. Why? Because you can write it as p by q. Yes? So this is a rational number. Whereas pi, it is not 22 by 7. It is, see, the thing is, we write it as 22 by 7 sometimes for the ease of our calculations. Yes? but it is actually equal to 3.14159265358 and then it keeps on going till infinity. Whereas 22 by 7 आप divide करके देखिएगा, this is another one of your homework. 22 by 7, when you divide it, your quotient will be 3.142857, 142857, 142857, and so on. This 142857 will keep on repeating. So you see, pi is equal to this, the value of pi, and 22 by 7 is a different number. Are you seeing how it's different?
Yes, ma'am.
Yeah. So pi and 22 by 7 are not the same, and we're going to discuss more about this. So this is also another example of irrational numbers. So I hope you guys will do your homework and come, and I'll see you again in the next class. Okay?
Okay, ma'am.
Any doubts?
No, ma'am.
No, ma'am.
Okay, thank you, class.
Thank you.